Jason, which goes through the air faster, light or sound?
Light.
Now, light goes at the same speed as radio. They're both electromagnetic waves. So today, you and I are going to measure the speed of sound. You know how to work a walkie-talkie?
Yeah.
Okay. Here's a pad and a pencil. Here, you want to put the walkie-talkie down because I want to give you the stopwatch.
Okay.
You know how to work the stopwatch?
Yeah.
Okay. I have a starter pistol.
Oh, okay.
So I'm going to get in the car and drive down way at the other end of the field. Over the walkie-talkie, I'll tell you how far away I am in meters. Okay. Then I'll give you a countdown with the walkie-talkie. 5, 4, 3, 2, 1. Then I'll fire the gun.
Okay.
The sound of the gun will go into the walkie-talkie over the radio, pick up on your walkie-talkie, and you will hear that bang, start the stopwatch.
Okay.
Then, by sometime later, the sound is going to come through the air. You stop the stopwatch.
Okay.
Okay? Think you got the idea now?
Okay.
All right, here we go. $100 meters. 200 meters. 300 meters.
Okay, Jason, you got that? 300 meters.
Roger.
Here goes the starter gun at 0. Are you ready with the stopwatch?
Just about.
Okay, here we go.
5, 4,
3, 2,
1.
That took 1.5 seconds.
Okay, Jason, you've got all the information you need to figure out the speed of sound.
Okay, so he was 300 meters away and it took 1.5 seconds to get here. So that's 15 to 3,000. We'll go 200 times. 200 times 15 is 3,000. 0. So that means that.
What'd you get?
Okay, I figured out that the sound was traveling at 200 meters a second.
Now you can go to the library and check the results of other scientists like you see, who've done this test, except they've used much more accurate instruments. And they've also recorded the same thing as you should right now, the various conditions under which you made the test.
Okay.
What are the factors that would have influenced the speed of sound as it came to you?
Air pressure?
Right. The more dense the air is, that would be one thing.
Temperature?
Yeah, the air would be thinner if it were hotter, right? If there were moisture in the air.
Yeah, okay.
And one thing?
Wind.
Wind, right. That wind could blow it either to you or from you or sideways and so forth. Anyway, your results after checking the measurements of the speed of sound as air is 200 meters per second. Congratulations. Jennifer's real interested in science, isn't she?
Yes, she is.
Okay, well, here's a good trick you can play on her.
Okay.
You have a piece of glass or plastic rod like this, and you say to her that this is a selective refractor.
What does that mean?
Well, a refractor is a piece of glass or plastic that bends the light. That's what the refraction means. And lenses. If you ever looked at something with a lens from some distance, you see it's upside down.
Yes.
That's because the light has been bent as it goes through there. And this is a cylindrical lens. So if you hold it over ordinary printing like that, see, you can...
Yes, it's upside down.
It's upside down, okay. But now you tell her this special kind of cylindrical refractor does that only to black light, not to red. So hold it over. See, if you hold it over the other thing, see what you see?
Oh, I see. The red letters are right side up.
Yeah, but the black ones are upside down.
But I don't believe it's a trick.
You don't believe?
It has to be scientific.
Well, it is scientific in that the light going through this rod is being bent just like it's supposed to, except take a close look at all the red letters. What happens if you... Yeah.
I know, because the red letters look the same upside down.
Yes. The H and the I and the C and the O and the D. You choose what you write and write those letters in red that look the same whether they're right side up or upside down. And it's amazing how many sort of people who know something about science will be fooled by that. So try it out on Jennifer. When you look up at the sky at night, how many stars can you see? On a moonless night with no clouds, you could count as many as 3,000 stars. But that's not even the half of it. On the other side of the Earth, you could count 3,000 more. Of course, through a telescope, you could see even more stars. Astronomers, looking through the most powerful telescopes, estimate they penetrate far enough into space to see 3 billion stars. But evidence recorded from beyond the reach of telescopes suggests there are many more stars out there. Astronomers have calculated that the total is in the neighborhood of 200 billion stars, more or less, because all the while, old stars are dying and new stars are being born. Tanis, I've collected glasses from all over the house and put them out here on the table so that we could play a glass xylophone.
Yeah.
You know what a xylophone is?
Yeah, I've seen those.
Have you ever done this with glasses? You fill them with
No,
water?
but
and
I've seen it before, but I haven't done it myself.
Well, start at the top with that little glass and take the spoon and wrap the
Okay.
side of the glass.
Okay.
Listen.
That one doesn't sound right.
Well, keep going.
Okay.
That's the bowl I had to
Yeah.
add because I didn't have enough. Every glass was too high. Now, if you're going to do these at home, would you start out find the smallest glass you can? Because what kind of a note will that give you? A high one or a low one?
high one.
A high one, okay. Then collect a bunch of them, and what is it that's making the sound in the first place?
The vibration and the water.
Of the glass?
Yeah.
Of the glass?
Of the
glass
glass.
is vibrating.
Yeah.
If you had water vibrating, you wouldn't hear any sound, would you?
No.
Okay, now in order to tune it, to make it the sound that you want to add mass. And that's when you add the water, right?
Right.
See that one that was out of tune?
Yeah.
Check it and see what has to be done to it.
It needs to have more mass in it.
Yeah, it's more. It's too high. Keep wrapping it, and I'll pour water in. Tell me when to stop.
Okay, stop.
Pretty close, yeah. I don't know what.
Yeah.
Some people have perfect pitch and they can tell exactly. I don't, but it sounds a little high to me, doesn't it?
Yeah,
Zero?
me too.
Try that. That's too much.
Too
Now
low.
you know what to do.
Take the water out.
Right, now try it. Hey,
Yeah.
good. Now, play a tune. When you have an instrument like this that is all just whole notes, the easiest tune to play, start up here like this.
Yeah, I've heard that
All
before.
right, try it down on this group.
Okay.
Wait a minute, you got to start here.
Oh, okay.
Did you hear this note? One of my favorites. Has a very watery sound.
Yeah,
doesn't
it does.
Not too good, but it's about as good as I could do. Now I thought maybe, now that you've been introduced to this, that we ought to try a duet.
Okay.
Can you play Silent Night?
I think so, yeah. I'll
Okay,
try.
start down here. Like that? Okay,
Yeah.
here we go. Where did you go off? Now you're up here? Go like. Go like that, right? It makes a nice sound, doesn't it?
Yeah, it sounds
So
pretty
sometimes
good.
on a nice rainy day or snowy day when it's too cold to go or messy to go outside, why, line up a bunch of glasses for your friends or your kid sister or brothers or something, and you can have a nice time playing all kinds of tunes.
Yeah. Mr. Wizard.
Oh, hi, Michael.
Here's the theme you said I could put on your word processor.
Okay. Come on, pull up a chair, though.
Okay.
Because before you get started, I have a spelling checker set up in the computer.
Oh.
Are you a pretty good speller?
No, I'm not really all that great at it.
Well, let me type something in here that'll make some mistakes, and you'll see how it works, so later you can use it.
Okay.
I'll put in the rain in SPAIN is mainly in the PLLAIN. How do you like that?
You made quite a few mistakes there.
Yeah, we'll see if the spelling checker can get them.
Okay.
So now I'll tell the spelling checker to go to work. And what is actually happening inside the computer is one of the disks over there has, say 50,000 words on it. And the computer, as you know, is pretty good at number crunching. It can, manipulate numbers. Well, it's also that way with words.
I see.
In that disk over there, all the words have been changed into numbers. And the words that I just typed into the computer are also now in numbers. And the computer is going to go look through those 50,000 words and compare them to every single one of my words. And the reverse. In other words, I had, 8 words or so. And it's going to take my first word, check every single one of the words in the 50,000 word dictionary, then the next one, and the next one, and the next one, and then bring back what I just typed and highlight it. You know what that is, where it changes it from white to black and so forth, and tells every word that could possibly be misspelled, including just typographical errors. So when you finish with your theme, you should be able to use the spelling checker to check your... Now, it won't tell you how to spell it, but it'll tell you when you're wrong. Okay, so I typed 9 words, and 3 of them, the spelling checker is something wrong. Now, you see what happened here?
Yeah.
It highlighted rain. Now, what you'll do is you'll push C to say corrected. Now, you'll go over here and you'll say R-A-I-N. Then you'll enter it. And then over it says, are you sure you're right? You say, yes, I'm sure. Whoop, it changes just like that. Now, here's mainly. I go down here to correct that again. Go over here and say M-A-I-N. And then run it over here and say yes. They say, are you sure? And I say yes. Now it's over there plain. Now I bring that down to correct it, and all I want to do is eliminate one of the L's, and then I go over here and say, okay, that's it. And they say, you sure? And I say yes. So that's how you use the spelling checker. So you ready?
Yep.
Okay, I'll get rid of this, clear the screen for you, and you can sit down and start typing in your theme, okay?
Okay.
All right, we'll go. It's all yours.
Okay. Oh, this will be great.
Okay, you've been checked out, so you don't need me anymore, can you?
Nope.
Okay, good
fine.
luck.
Okay.
Fighting a forest fire is a big job that may involve hundreds of men and special equipment. Even after the fire is under control, firefighters can spend days putting out isolated hotspots. At last, the fire is out, but the job is only half done. You see, after a forest fire, heavy rains can lead to disaster. Water pouring down the bare hills can carry away tons of soil and rock. So, as soon as the fire is out, specialists from the U.S. Forest Service examine the area in detail. They check the roots of the grasses for signs they will sprout again. They examine the soil to see how well it can absorb water and hold together. They estimate how much ash and mud will be carried off into the streams. The information is sent to headquarters, and in a matter of days, a forest rehabilitation plan is put into action. A helicopter spreads a mixture of grass seeds and fertilizers onto the burned area. On the ground, a team spreads the seeds of plants eaten by wildlife to encourage them to return. A dead tree is positioned to act as a terrace to slow the water coming down the hill. Debris clogging streams must be cleared away. Trucks could damage the bare ground, so a helicopter becomes an aerial crane to remove heavy logs. A few months later, the burned area is on the way to recovery. So the next time you hear that a forest fire is under control, you'll know that only half the job has been done. The other half begins when the forest fire is out. Jason, here's a window, drawing of a window anyway.
Okay.
I've got it on a little stand here, a special kind of motor down here. I'm going to turn it on. I want you to look at it, but stand back here
All right.
and look at it with one eye.
One eye?
Okay, one eye. Are you ready?
Ready.
I want you to tell me what you see.
Okay, the window is moving about half a turn to the right, then it turns around and moves half a turn to the left.
I mean, it's going back and forth.
Yeah, it's kind of oscillating.
You sure?
Yep.
Well, I won't turn the motor off or anything. I'll simply tip it so that you can see what's really happening. Look.
What? Oh, it's actually rotating around.
Yes. Now I'll turn it back up here like this. Straighten it up for a second. And you look. It'll go oscillating back and forth again.
It's oscillating again. I don't...
We'll crook it yet. There.
Why is it doing that?
Well, that's because it's an optical illusion in motion. Come on up here, I'll show you.
Okay.
When you see a window like this, it's usually along the side of a building at that perspective. This front part, the long part, has got to be more closer to you than the rear part, which is smaller.
And it looks farther away.
It looks farther away. So therefore, regardless of which side you look at, that part's always going to be, by your mind, put as far away as it can from this one. So in spite of the fact that you now know it's rotating, every time you see that section back here, the small part, your mind's going to push it away, and that's what makes it vibrate or oscillate back and forth.
That's neat.
Okay, I'll try it again. Then I'm going to add something. Go ahead. Go back there and look at it with one eye.
Okay.
Is it going back and forth?
Yeah, it's oscillating again.
It's oscillating again. Okay, now I'm going to put on something that's not part of the optical illusion, and you watch what happens.
Is that just a soda straw?
That's a soda straw. What happens?
Oh, it looks like it cuts through the window.
Yes, because it continues to rotate while the window continues to appear to oscillate back and forth.
Every second time it oscillates back and forth, it kind of cuts right through.
Cuts right through the
right
window.
Right there.
Yeah, come on up here now. You see, when you get up real close to it, you can see that the window is continuing to go round and round, and so is the soda straw. And it's a neat optical illusion that you often find at science museums. And here's how you can sort of do this one at home. Make out a window shape, draw it out carefully like that, put it on a rotating shaft, and it'll look like it's oscillating. This is the top of a plant you no doubt have eaten. The bud has been opened up so you can see some of the parts inside. Eventually, the parts would have grown into many fine branches that give the mature plant the look of a fern. Long before that can happen, the young shoots are harvested and end up on your plate as asparagus. Lila, do you see that tree out there?
Yeah,
How tall is it?
I don't know.
Well, how could you find out?
Well, I could go to the top and drop a tape measure, but I think that would take too long.
Well, why not do it with a pan of water?
A pan of water?
Yeah.
How do you measure a tree with a pan of water?
Well, come over here, I'll show you. I have it all drawn out for you. First, you have to find out something about triangles.
Okay.
Here's the tree.
Yeah.
Measure the height of the tree here on the drawing.
Okay. That's 20 centimeters.
Okay, so put 20 right there. Now measure the distance from the base of the tree to that point right there.
Okay. That's 22.
20 also.
20 also.
Okay, not 22. So they're both the same.
Yeah.
Now notice this was a right triangle, and here's another little right triangle. Same thing, exactly the same except for their difference in size. So measure those two sides and put the numbers in there.
Okay. That's 5. And that's 5.
Okay, so put those two numbers in. So you see, if you stood down here and you sighted along here and you sighted up to the top of the tree, and you were sure that that was the proper angle here, you could quickly tell by measuring from this distance to here what that distance is. You follow me? If
Yeah.
this is the same and that's the same, then if you found those two, you'd be able to make the comparison. Well, you see that triangle just flipped around over here to the other side? Same
Yeah.
sort of triangle, isn't it?
Yeah.
Now all we have to do is find the height of your eyes.
The height of my eyes?
Yes, come around over here.
Okay.
Now I'm in inches, feet and inches, because that's my long ruler. It's 4 feet 2 inches. So
Okay.
write 4 feet 2 inches right there. Okay, now write 4 feet 2 inches right there.
Oh, I get it. If this distance is the same as this distance, then this distance is the same as this distance.
Yes.
And this is the height of the tree.
Right. Now all we have to do is make sure that these two angles are the same. Now we could put a mirror down there because light, as it would be going from the tree, would bounce up to your eye, and that would guarantee that the angles are the same. But if you put a mirror down here, you're not sure that it's absolutely level, and it's got to be in order to make those angles the same. So that's where the pan of water comes in. Pan of water. Pan is painted black. If I put water in it, the top surface acts as a mirror. Look in there. What do you see?
Your head.
Yes. Now, if instead that were the top of the tree, we'd have the two angles, wouldn't we?
Yeah, from here to there to there.
Right. Okay, so let's empty it out and go out and actually do it.
Okay.
You take the tray and the tape measure, and I'll take the screwdriver. Now, remember, this is going to be the important thing. We've got to make sure those angles are the same with that pan of water. Come on.
So that's how you do it with pan of water.
You see the top of the tree in the water now, Lila?
Yeah.
Okay. Now, we've measured the distance from the center of the pan to the bottom of your feet, 4 feet 2 inches. What's the height from there up to your eyes?
4 feet 2 inches.
Okay, so how do we find the height of the tree?
You take this, the tape measure, and you take it from the dish all the way to the bottom of the tree. And
That's
that's
gonna
the
be the
same
height?
length as the height of the tree.
Okay, here you are. Let's try it. Okay, how tall is the tree?
26 feet 3 inches. Is that the right answer?
Well, Lila, when you make measurements like this as scientifically as you can, you have to do the same as scientists do. You have to be very accurate in figuring your angles and measuring your distances, and then you might want to do it 2 or 3 times to check it. So I have to ask you, is that the right answer?
I think so.
Okay, good.